Video is about scientific notation and how we write numbers in scientific notation to standard form and standard form to scientific notation. So to begin with, what is scientific notation? We use scientific notation to express very large or very small numbers. So if we were thinking about the distance from the Earth to the Sun, that would be a very large number. So we would want an easier way to write those really, really big numbers. Or if we were thinking about the size of an atom, that would be a very small number. So we write scientific notation as some coefficient, in this case it's represented by the letter A, times a power of 10. So this letter A always falls between 1 and 10. It can be equal to 10, or it could be equal to 1. It cannot be equal to 10, or it could be any number between 1 and 10. And then we multiply it by a power of 10, where our exponent tells us the number of spaces in which direction to move our decimal point. So let's think a little bit more about that on this next slide. So if we start with scientific notation and we try to convert it into a regular standard form number, we might have something like 3.4 times 10 to the 7th power. So my exponent is a positive 7. This tells me that when I multiply 3.4 by 10 to the power of 7, my number is going to be getting bigger. It's going to be getting larger because I have a positive exponent. So I want to move my decimal point 7 spaces to the right. So when I have a positive exponent, I move my decimal point to the right. So in this case, if I start with 3.4, I'm going to move that decimal point 1, 2, 3, 4, 5, 6, 7 spaces to the right. In each of these blanks, I can add in a 0. And I see that my final answer is 34 million. So 3.4 times 10 to the 7th power is 34 million. Sometimes scientific notation problems have negative exponents. So let's say I have 4.6 times 10 to the negative 8th power. When I multiply by a number with a negative exponent, my value is going to be getting smaller. So when I have a negative exponent, I'm going to move that many spaces, but to the left. So in this case, I'm going to move my decimal point 8 spaces to the left. So if I start off with 4.6, I take that decimal point and I go 1, 2, 3, 4, 5, 6, 7, 8 spaces to the left. Again, in all of these blanks, I'm going to add a 0. So I see that 4.6 times 10 to the negative 8th power is equivalent to 0.000000046. Okay, if you want to pause the video and practice these two problems and then replay the video to see if you got them right, that would be fine. So 3.7 times 10 to the 5th power, my exponent is a positive 5. So I'm going to move my decimal point 5 to the right. So I have 3.7. I take that decimal point 1, 2, 3, 4, 5. I'm going to add a 0 in all of my blank spaces, and I see that my final answer is 370,000. For our second problem, we have 4.612 times 10 to the negative 2nd power. My exponent is negative, so I'm moving 2 spaces this time to the left because my value is getting smaller. So 4.612, I take that decimal point 1, 2 spaces to the left. I add a 0 in my blanks, and I see that 4.612 times 10 to the negative 2nd power is equivalent to 0.04612. Okay, we can also go the other way. So instead of starting with a number in scientific notation and writing it in standard form, we can start with a number in standard form and write it in scientific notation. So going over those steps, our very first step is to figure out what our coefficient is going to be. So remember, we have some number times a power of 10. The first thing that we're going to need to figure out is what our coefficient should be. So in this problem, it looks like we have the number 3,450,000,000,000, which is obviously not between 1 and 10. So I'm going to put my decimal point right here between the 3 and the 4. So I see that my coefficient is going to be 3.45 times some power of 10. My second step is to count how many spaces I moved that decimal point, and that number will become my exponent. So I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. So I know that my exponent is going to have a 12 in it. Now I just need to decide if my exponent is going to be positive 12 or negative 12. So there's a couple ways to figure this out. The first way is if my original number was larger than 1, then my exponent is positive. So in this case, 3,450,000,000,000 is much larger than 1, so I know that my exponent is going to be positive. The second way that I could think about it is if my coefficient is 3.45 and I'm multiplying by some power of 10, 3.45 is smaller than 3,450,000,000,000, so I need to multiply it by a positive power of 10 in order to make that number bigger. So in this case, my final answer would be 3.45 times 10 to the 12th power. If my original number was less than 1 or my coefficient is larger than my original number, then my exponent would be negative. Okay, we have 2 practice problems. If you want to pause the video and practice on your own and then check your answers, that would be great. So let's start with this first problem. We have 0.00005178. So step 1 is to place my decimal point so that my coefficient is between 1 and 10. So in this case, I'm going to put my decimal point between 5 and 1. So my coefficient is going to be 5.178. And now I need to count how many spaces I moved that decimal point. So I moved it 1, 2, 3, 4, 5, 6 times. So my exponent is going to be some power of 6. Now 5.178 is much larger than my original number in standard form. So that tells me that my exponent is going to be negative. Also, my original number is smaller than 1. So again, my exponent is going to be negative. Okay, 6,789,000. So step 1, place my decimal point so that my coefficient is between 1 and 10. So 6.789. And then step 2, count the number of spaces I moved my decimal point. 1, 2, 3, 4, 5, 6. In this case, my coefficient is smaller than my number in standard form. So my final answer is going to have a positive 6 exponent. So I see that 6,789,000 is equivalent to 6.789 times 10 to the 6th power.